carbon ion formed is resonance stabilized. Obviously, there's a water present in our solution. This is going to donate its lone pair either to this carbon or this carbon. So hello my dear student, how are you all? So I welcome you all to Allen Overseas. So as you already know that in 45 days we are going to cover 45 topic, and today we are going to see one of the topic of the chemistry, and this is very important for all the students who are preparing for JEE Mains. So without any delay, let's start with our topic and let's see what's the topic that we are going to cover in our chemistry. So the name of the topic is Aldol Condensation, which is the part of your name reaction. And every year, at least one question is asked from this topic, or at least alternate year, one question is asked from this. So without any delay, let's jump to our topic. So the first thing that you should know is the enolate ion, which we are going to use to make our aldol. So firstly, like over here, you can say, sir, your aldehyde is given. Yes, this is your aldehyde which is given to you. And like basically, in all the aldol reaction, the main important part will be this. If this group is present and just beside this, there should be an alpha carbon present which should have an alpha hydrogen, then only you can proceed with this reaction. Why? Because over here you will see there is a base which is ready to give its lone pair. And like what is going to happen? Like firstly, it is going to create an enolate ion. And how actually it is produced? So over here, there will be one hydrogen like this. Over here I write 2. So instead of like I distribute them throughout, and one hydrogen will be released from here. What is going to happen? One hydrogen will be released from here, and this H plus which is released, this lone pair is donated over here, and HB is formed. And because NH plus is removed, so over here there will be a negative sign on CH2. And this is, if you will see over here, you can see one thing important, which is now this becomes resonance stabilized. And that's why an enolate ion is formed. Can you see? There is a resonance stabilized. And that's why a statement is also written. This reaction take place because carbon ion formed is resonance stabilized. That's why like this is like because an enolate ion is formed, which is you can say your resonance stabilized. That's why this carbon ion is formed. Once we know this, now the reaction is very easy. Once we know how actually your enolate ion is formed, now we can easily understand the mechanism of your aldol reaction. How? First of all, there will be an aldehyde given to you. No problem with that. In presence of an dilute NaOH. So there is, first of all, this is a diluted and there is an NaOH. It means there will be Na plus and OH minus present over here. Yes or no? And what is going to be produced? An aldol is going to produce, which will be your beta hydroxy aldehyde or ketone. This we are going to talk about in detail once we have understood what is actually like what is the mechanism to produce your aldol. So let's first focus on that. So we have this aldehyde over here, and from here, can you see there is an OH minus present, which is going to acting as a base. So from here, what is going to happen? This one hydrogen will be released and enolate ion will be formed, like a carb ion. So what is going to happen? From here, one hydrogen will be released and it will be given to this. And what will be produced? There will be an H2O. Can you see? There is an H2O produced because from here, one hydrogen will be going to here. But how? Because firstly, an hydrogen will be released, like there is a hydrogen, this is going to break, and there will be an H plus and there will be an ion produced like this. So there will be an enolate ion which is formed over here, which is your resonance stabilized, we just saw, and there will be an H2O molecule which will be produced because now the lone pair will be donated to this and your enolate ion is going to be formed. So this is the basic part. Once we have this enolate ion, if you will see, what did we had at the beginning? We had our aldehyde, and now we have produced from this, we have produced our enolate ion. So in the beginning, there was an aldehyde. So in a beaker or wherever you are performing, there are many molecules of this aldehyde which are present. So it means this enolate ion can further react with itself, or you can say with an aldehyde which is present over here. Let's see how. Like this two will be present. How? One we are going to take from here and one from your enolate ion, which was actually formed by this only. So now we are actually using two molecules of your aldehyde over here for one which will be directly reacted and one which we have converted into our enolate ion. So let's see how. So once this enolate ion is formed, what is going to happen? So over here we know one thing, which is like in comparison to carbon and oxygen, this is more electronegative, so there will be partial negative charge and there will be partial positive charge. And because this is your carbanion, so this will be readily able to give a lone pair over here. And to donate a lone pair, what will be happen? This double bond will go to this, like this double bond pair electron will go to this oxygen, and this compound will become something like this. So what actually you can see, there's a CH3, this CH3 is there, and this double bond has gone to this oxygen, that's why there's a negative sign. And now this CH2 is directly attached to this carbon, so this hydrogen we have written over here, and this part we are directly attached to this. So can you see over here, it is directly attached, and afterwards this has a C double bond O, and hydrogen present over here. Like this, we can perform our reaction. And once we get this, so if you will see, initially what did we use? We used diluted NaOH. So obviously there's a water present in our solution. So this can further react with our water because form diluted base. So if there's a water, what does water have? Water have H plus and OH minus ion. So over here, this H plus ion can be attracted by this, and this can be go like this H plus can go to this O minus, and this product will be formed. Yes or no? So in the end, what actually is produced? So from here, H has been accepted by this from your H2O, and over here we get our OH minus. So if you will recall, at the beginning we used our OH minus, and in the end of the reaction, OH minus is actually produced. It means OH minus over here is acting as a catalyst. Okay, so now we understood the rough idea of the reaction, how the reaction is going to happen. And like I was telling you, like we will talk about your beta hydroxyaldehyde. Let's talk about that. So this is the general idea. We use two molecules of your aldehyde over here. Yes, and in presence of dilute NaOH, what is actually produced? This is produced. And what is this actually? This is nothing like over here. This is your alpha, this is your beta carbon, and this beta carbon has an hydroxy. That's why we can directly call this as beta hydroxyaldehyde. And instead of this hydrogen, if there would be a CH3, so this would become your ketone. This would have become your ketone. That's why we can either call it as beta hydroxyaldehyde or beta hydroxy ketone. So this is the general mechanism of your aldol reaction, and this is nothing but your aldol. That's why I told you. Afterwards, we will understand what is actually your aldol, and this is your aldol. And you can also remember it one more way, like this is your aldehyde group and that is an alcohol group. That's why in short this is also called as aldol. Aldehyde plus alcohol, we can call this as aldol. Now the definition of your aldol reaction is aldehyde and ketone having at least one alpha hydrogen. This is very important. Like what actually happened, this hydrogen was present, that's why this was able to go outside, and over here an anion was formed, and then after that we were able to do the reaction. It means your alpha hydrogen is very important over here. So aldehyde and ketone having at least one alpha hydrogen undergoes a reaction in the presence of a dilute alkali as catalyst. Like I have also told you why it is going to act as catalyst, because at the beginning it gave us OH minus, and in the end that OH minus was produced. That's why OH minus was acting as your catalyst to form beta hydroxyaldehyde, which is nothing but your aldol, and this reaction is called as our aldol reaction. So this was the general idea of your aldol reaction. I think so everyone understood how actually we, like, what is the mechanism of your aldol reaction. But sir, what about aldol condensation? So over here, once we get this aldol, what's the next thing that we can do? We can like heat this, and what is going to happen over here? A water molecule is going to be produced, or it is going to be released from this aldol. So over here, H2O is going to be released. How? There's an OH present over here, and there's one hydrogen from here. So over here, there will be double bond which will be present, and this is nothing but your aldol condensation. So over here you can see the name aldol is derived from the name of two functional group, aldehyde and alcohol, present in the product, like I told you. The next part, the aldol readily loses water to give alpha beta unsaturated carbonyl compound, which are aldol condensation product. and the reaction is called as aldol condensation, because this is an aldol condensation product. That's why this type of the reaction is called as aldol condensation. So now we got the rough idea like what is your aldol condensation and how the reaction is going to be proceeded and everything. So now we can directly proceed with the questions. And if you will see the question which I have already taken in the mechanism, first I will give you a simple trick. Like whenever like we don't have to go through all the processes which we have done right now, we can directly write the product in easier way. So in the first slide, I'm going to show you how actually we are going to do it. And afterward, we will directly do, like we can directly write the product also. How? So let's say this is the question. This is the same question which I have taken in the reaction mechanism. So whenever there's a question like this, what you have to do? You have to write this twice. You have already written this as twice. And just do one thing. Because we just know we have to make an enolate ion. What we are going to do? Either like right or left, specially make this one as your enolate ion. So make that as the negative sign and this as 2. Yes. So I can directly write this for idea. I'm going to write this over here. So this part I can directly write like this. Yes or no? There's a CH3 C double bond O H and there's a CH3 C double bond O. Like this is the part which will be given to you in the reaction, and from that you have to get, okay, over here we have to do aldol condensation. So that's why we are going to write this twice, like directly like this, and one part you have to write a negative sign. This was just for the idea, like you have to write like this twice and make one as enolate ion. Once you have made this, now the rough idea from the mechanism we have this, like this is going to be go over there and this will come up here. So the next product I can directly write this. So this CH3 will over here. This will have a single bond O minus, this carbon, this hydrogen is over here, and this is directly attached to this part. Can you see? This is the linking part which is there. This is the linking part and this part is directly attached. And the next part is there, like because this is there in the water. So the final product will be this. Because there will be an H2O. From this H2O over here, there can be an hydrogen which can be accepted by this, and this product is formed. And over here, if you will see very carefully, this carbon is actually chiral carbon. Yes or no? And if there is a chiral carbon there, so there will be 2 products. So I will write 2 products are formed because it can react from the front side as well as from the back side if there is a chiral carbon present. And there are 2 products, and someone asks us, sir, why there are 2 products? Because there is one chiral carbon present. So this is the rough idea, like whenever there's a reaction or whenever there's a question asked, we can directly perform the reaction very easily. We don't have to go through whole mechanism. Let's see another question. Like if this question is given to me. Now this is your ketone. So there is a dilute NaOH. So we are going to write this twice. One. But second one should have an carbon ion. So if this is your carbon ion, what's the next thing that I'm going to do? I'm going to transfer this over here and this is going to go up. Yes or no? So this is the general idea which we have followed. So this is going to go up. This is going to go up. So I can directly write the product. So this whole thing will be there. This CO minus will be there. Now previously it was hydrogen, but now this is CH3. So that's why over here there's CH3. And these 2 are actually linking. Yes or no? These 2 are making the link over here. And because these 2 are making the link, that's why we will make them together over here. Yes. And rest everything is directly attached. And afterward we will actually going to put the water. So this is going to have our hydrogen over here and this will be our final product. And over here, can you see a chiral carbon? No, because there is no chiral carbon. There will be only one product formed over here. Why only one product? The previous one had 2 because it had an chiral carbon. It only is going to have only one product because there is no chiral carbon. So this is the general idea. Let's do another question. If this question is given to you, we don't have to panic. Just write it twice. But the another one which we are going to write, it should have, like this is our group. So there should be an alpha hydrogen. So there is no carbon. There is carbon which have an alpha hydrogen. So we are going to write a negative ion to this. Yes or no? And now this is going to be donated over here. Yes. So if this is donated over here, this is going to go up. This part over here is going to go up. So over here, what actually I can write? Directly firstly write this 2 part. This 2 part. This C will have O minus over here and this hydrogen will be there. And this is actually directly connecting to this carbon and this carbon. So this carbon has one CH3 over here. And this carbon also has C double bond OH. So this carbon is actually going to have C double bond OH. So this is the product, and once I introduce my H2O over here, what will be my final product? Instead of O minus, there will be OH. And over here, if you will see very carefully, how many chiral carbon are there? There are 2 chiral carbon. So sir, how many products should be formed over here? There will be 4 products, because 4 products are formed. Why? Because 2 chiral carbon are present over here. That's why over here there will be, what you can say, a 4 product will be formed. So now this was the general idea how actually we are going to solve. So let's see a few more questions based on this. So like if this question is given to you, obviously first either you can use this or this as your alpha hydrogen, because in both the situation there will be an alpha hydrogen. I can use either one. So over here this is there. So over here I will make first ion, like carbon ion. There will be another part, and now this will be donated to this directly over here. So I can directly say there will be a link between this carbon and this carbon. Yes or no? So how actually I can write the product? The product will be written something like this, and this double bond will go to this oxygen, and there will be a negative sign. And now as I introduce the water, what is going to happen? This product will be formed, and there is 1 chiral carbon. So how many product will be formed? 2 product will be formed, because there is 1 chiral carbon. So I think so you got the general idea how actually your aldol condensation reactions are going to happen, and how actually we are going to write its final product. Yes or no? So now this is the last question which we can take to understand how actually your aldol condensation reaction happens. Even if this type of the question are also given, always see for one thing, there should be an alpha carbon present, or there should be an alpha hydrogen. Like even if there's a carbon but it do not have any hydrogen, in that situation we cannot perform the reaction. So there should be an alpha hydrogen present, and there is an alpha hydrogen present. So we are going to write this twice, but like the carbon which have the alpha hydrogen, that we are going to convert as your carbon ion, like this. And because this is your carbon ion, obviously this part from here will be donated to this. This is going to go up, and I can directly write the product. Yes or no? This will go directly up. This is directly attached to this carbon. So this CH3 has gone down. This is directly attached to this. This has C double bond O, and this C double bond O is connected to this compound. Yes or no? So like this is going to be there. And once I will introduce our H2O, this O minus will become OH minus, and this is our final product. And this is how actually we can write our product when we are doing our aldol condensation. So this was the general idea how actually we are going to perform the reaction, and how actually we are going to write the products. And there are few actually variation, like there is a cross aldol reaction, and like how actually we are going to perform this type of the question. Like if you will see over here, like if this question is directly given to you and they will tell you write the reaction. So if this is not given, you can easily write. But if these two are given, first of all tell me, is there an alpha hydrogen present over here? No. So it means I cannot convert this into our carbon ion. Yes, we cannot do this. But yes, there is an what you can say a molecule present which has an alpha hydrogen. This I can convert into carbon ion. So I will convert this. So over here, if you will see what is going to happen, there will be an Na plus OH minus. So from here I'm going to get my OH minus. This will be reacted with this part, and this will be converted into this enolate ion. Yes, this part we have already seen. But now over here, this enolate ion can either react with this and this. But because over here, what actually the condition, like this is going to donate its lone pair either to this carbon or this carbon. This will depend upon its partial positive, like there will be partial negative charge over here. Partial, like this will be partial negative charge, this will be partial positive charge, this will be partial negative charge, this will be partial positive charge. But because there is an plus I effect which is already present over here, so this enolate ion is going to donate its lone pair to this compound. So the solution will be something like this. So this will be donated to this carbon, and how actually your compound is going to form. That's what this is called as cross aldol reaction, because aldehyde is not reacting with its own kind of, like this enolate is not giving its lone pair to the same kind of the compound from which its enolate is formed. It is giving to the another one. Why? Because over here this will be more stable part. Okay, much easier part. And now once this is done, what is going to happen? This is going to go up, and there will be a negative charge. There are 2 hydrogen which are present, and this is directly connecting to this. So this will be CH2, and there will be C double bond OH. And as I will introduce the water, what is going to happen? There will be an OH over here. Can you see? There's an OH already formed. So from here I can easily form my OH. OH will be formed, and like this we can perform our cross aldol reaction also. There is one more type of the reaction, like how actually there was a cross aldol reaction. There is one more, like this was the general idea how actually you can write the reaction. Like this two are there. Now from right now you can directly write the product also. Now the second one is your intramolecular aldol reaction. What do you mean by this? Now in this part, if you will see, like previously there were two different molecules which we like in which we were doing our aldol reaction. Now this is one single molecule which is there, and this can also perform the reaction. Why? Just see, if I will see this part, yes, over here, can you see there is an alpha hydrogen over here also? There is an alpha hydrogen over here also. So I can either perform reaction from here or I can perform reaction from here. And there is an C double bond O also present over here. So over here there will be partial negative charge, there will be partial positive charge over here. So now what can happen? Let's say I make this, like I'm making them as an ion, like I'm assuming like a negative charge is released from here. Like there's a hydrogen release. Let's assume that. So there will be a negative charge over here, or there can be negative charge over here. And this can be directly donated to this carbon, and this can also be donated to this carbon. But we have to keep one thing in mind. Like I'm assuming like this hydrogen has been released. Okay, in that situation, like there will be two hydrogen over here and there will be only one hydrogen. Like if I'm making them as carbon ion in that situation. Okay. So now if you will see, when I'm going to make from here to here, how many carbon cycle will be there? 1, 2, 3, 4. But if I make from here to here, how many carbon cycle will be there? 1, 2, 3, 4, 5, 6. Now just tell me between 4 carbon chain and 6 carbon chain, which is more stable? Obviously 6 carbon chain is more stable. That's why instead of this, we will donate the lone pair, or like we will make the compound from here, and this is going to look something like this. But sir, how? Let's see. So over here, write the number. This is 1, this is 2, this is 3, this is 4, this is 5, and this is your 6. So now over here, if you will see what is going to happen, because this is donated through here, like I can write like this for your betterment. Like I can write CH3, like instead of CH3, I'm going to write CH2, and an ion is formed. CH2, 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 C double bond O, CH3. Now, number of the carbon, write the number. This is your 1, this is your 2, this is 3, this is 4, this is 5, and this is 6. And because I'm going to donate this from here to here, what is going to happen? This is going to go up and this will become like this. So this is your 6th carbon. Yes. And this is your 2nd carbon. Yes. Like for the naming part, it will be much easier. So over here, how actually I should have like started the numbering part. This is directly connected to the 6th one. This is directly connected. So this will be my 1. So this is 1, 2, 3, 4, 5 and 6. So over here I can easily verify, like on the 6th carbon there will be O minus and CH3. Yes, there is O minus CH3. On the 2nd carbon there will be C double bond O. Yes, there is C double bond O. And now I am going to introduce water over here, and because there will be water, this OH, like O minus will become OH over here. Like this is your intramolecular aldol reaction. So now we understood what is your intermolecular aldol reaction. We have already seen what is your cross aldol reaction. We have seen the mechanism of the aldol reaction, how the aldol is produced. Like over here also we saw the intramolecular aldol reaction. And if you will see, like we were doing our aldol condensation. So in the condensation part, we have to just see over here we have to provide with the heat. So over here, like if I will transfer, like if I will provide some heat, what is going to happen over here? The water is going to be released. How? There will be one hydrogen over here. This OH and this hydrogen is going to be released. And like in short, H2O is going to be released. And this is the product which is going to be formed. So like this, we can easily write the products if they are going to ask us. So let's see one more question from the JEE which has been asked in your 2021. What the question says? Aldol condensation take place in aldehyde, ketone or both or none of the above. So we already know the answer. Why? Because for the aldol condensation, the thing which you have to keep in mind is there should be an alpha hydrogen, and both your aldehyde as well as ketone both are going to have your alpha hydrogen. That's why the correct answer for this question is your option C. But sir, why? Why can't your A, B, C, like all the 3 can be correct? Because this is your JEE main question and it is your single choice correct answer. That's why the correct answer is your option C. Let's see the answer. So the answer is Your correct answer is your option C, which means both aldehyde and ketone are going to show your aldol condensation. So that's all from my side onto this topic. And you can see the whole series. The playlist is actually there in your description box. And if there is any suggestion, you can comment us. And that's all from my side. Stay tuned with us. Thank you.